Me and my partner Spencer took a look at the 2018 Hyundai Tucson's O2 sensors to understand how they functioned and worked in the vehicle. The Hyundai was equipped with two oxygen sensors. One could be found in the engine bay behind the engine, and the other was found underneath the car in the exhaust system.
According to all data, the heated oxygen sensors consist of zirconium and alumina and is installed both upstream and downstream of the manifold catalytic converter. The sensor output voltage varies in accordance with the air-fuel ratio. The sensor must be hot in order to operate normally. To keep it hot, the sensor has a heater which is controlled by the ECM via a duty cycle signal. When the exhaust gas temperature is lower than the specific value, the heater warms the sensor tip. The first HO2S sensor, or Bank 1 Sensor 1 sensor, which is located upstream of the catalytic converter, is a 6-wire system. Wire 1 provides nursed cell voltage, wire 2 is power supply, wire 3 is the ground, wire 4 is comprehensive resistance, wire 4 is HO2S B1/S1 heater control, and wire 6 is the pump cell voltage.
This sensor is a wideband style. The second sensor, or HO2S Bank 1 Sensor 2, which was located downstream from the catalytic converter, was a 4-wire system, with wire 1 being sensor ground, wire 2 being HO2S Bank 1 Signal 2 signal, wire 3 being HO2S Bank 1 Sensor 2 heater control, and wire 4 being power supply to the system. This was not a wideband type sensor. We decided to hook up a scan tool to the vehicle's OBD2 port so we could accurately see what was going on inside the sensor and how it changed with different operating conditions. We started by looking at the values of the short-term and long-term fuel trim at idle. Those values turned out to be pretty good, so we decided to do a vacuum leak to see how it would affect the short-term and long-term fuel trim. It is easy to see when the vacuum leaks were created because of the humps on the graph. You can see that the long-term fuel actually goes down when a vacuum leak is created and then jumps back up when the vacuum is plugged. But the short-term fuel starts to bring that long-term fuel number down as soon as it is plugged. We also wanted to look on the scan tool to see how the different RPMs would affect fuel trim. Fortunately, the readings were all relatively normal, meaning nothing was wrong with our O2 sensors. We did another vacuum leak at 2500 RPM just to see what would happen, and it gave us similar fuel trim readings to what it was when we just did it at idle. We then brought out the picoscope so we could connect it to the O2 sensor to see what the signal actually looked like that was coming from it. With everything connected, we were looking at Bank 1 Sensor 1 with the key on and the engine off. This was the signal that we found. During startup, we were able to find this waveform on the picoscope. We then checked it while it was idling. We wanted to make sure we were getting accurate readings, so we let it idle for a while and watched the scope. Nothing out of the ordinary was ever found. To see how it would affect the signal, we then brought the car's engine up to about 2500 RPM and observed the wave. It jumped up a bit, but as the car returned to idle, it went back down.